This is a subsequent video of the previous class, and in this video, we will be covering types of devices that we commonly use in our network. There are a lot more devices that can be part of the network. However, before we start, there are a few definitions which I need to speak about so you can understand the terminology we will be using. Let's understand first, what is a domain? Actually, it is a kind of boundary defined as a geographical area or logical area where anything in it becomes part of the domain. In computer land, this means that when something happens in this domain, every computer that is part of it will see or hear everything that happens in it. Now let's understand what a collision domain? Putting it is very simple. Whenever a collision between two computers occurs, every other computer within the domain will hear and know about the collision. These computers are said to be in the same collision domain. As you are going to see later on, when computers connect together using a hub, they become part of the same collision domain. This does not happen with switches. Another one is broadcast domain. Let's understand what is broadcast domain. A domain where every device is part of the same family. If something happens within the domain, broadcast is seen by all computers or members of the family within the domain. Hubs and switches do not break up broadcast domains. You need a router to achieve this. There are different devices which can break up collision domains and broadcast domains and make the network a lot faster and efficient. Switches create separate collision domains, but not broadcast domains. Routers create separate broadcast and collision domains. Hubs are too simple to do either, cannot create a separate collision or broadcast domain. Let's start with hub and know more about hub. It is a physical layer device, and it is also called as dumb device. A hub always operates at half duplex, so only one device at a time can communicate to others because it has one collision domain and one broadcast domain. Hub does not have any mechanism to store end host identity like switch. It does not read the data frames at all, like switches and routers do. It only makes sure the frame is repeated out on each port, and that is about it. The computers connect to the hub using unshielded twisted pair cable, UTP. Hub creates a shared segment. It means the bandwidth will be shared across the devices connected to the hub. Let me explain. You have an internet connection with the speed of 100 Mbps, and you are using hub to connect all your 5 devices. In this case, all 5 computers will not be operating at 100 Mbps speed. 2 out of 5 might be operating at 30 Mbps, and others might be using 25 Mbps speed. If one computer is busy in sending some data to another computer, the rest of the computer's bandwidth will be disturbed. It happens just because the hub has one collision domain and one broadcast domain. The nodes that share an Ethernet or fast Ethernet LAN using the CSMACD rules are said to be in the same collision domain. In a simple way, this means that all nodes connected to a hub are part of the same collision domain. In a collision domain, when a collision occurs, everyone in that domain will hear it and will be affected. The Ethernet section talks about CSMACD and collision domains since they are part of the rules under which Ethernet functions. Now, let's understand the switch. Switch is a data link layer device, and it is a full duplex device. It provides multiple ports to connect the end host. It provides the dedicated speed to each port, and it creates a span of local area network. The switch has multiple collision domains and one broadcast domain. It means if a device sends data to another device, it will not be impacting another device's bandwidth. As we said earlier, hubs work at the first layer of the OSI model and simply receive and transmit information without examining any of it. Switches are a lot smarter than hubs. What this means is that a switch would not simply receive data and transmit it throughout every port. Rather, it will read the data and find out the destination device identity by checking the MAC address. The destination MAC address is located always at the beginning of the frame, so once the switch reads it, it is forwarded to the appropriate port, so no other node or computer connected to the switch will see the data. Let's understand the router. Router is a network layer device. A router is a device that connects two or more packet-switched networks or subnetworks. In layman language, it has the capability to connect two or more LAN networks and allow them to communicate with each other. Even it has a mechanism to store the information of local networks as well as destination networks. The router has a dedicated collision domain and broadcast domain for each port. A router's job is to perform routing. Let me explain with an example. What is routing? AJ has an office in a two-story building. He has some devices on the first floor and some devices on the ground floor. Now the problem is, the ground floor users are not able to communicate with first floor users. He is now looking for a solution to fix this problem because he has divided this office in two networks, ground floor and first floor. Whenever such a situation comes, we always bring a router to solve the problem. Now after deploying a router in the network, the ground floor users can communicate with first floor users or vice versa.